Hello and welcome to Easy Maths. In this lesson I'm going to take you through simple trigonometric graphs, and I'm going to do it in two videos. The first video will have an introduction to what trigonometric graphs looks like, that is a sine, cosine and tan, and then the second video we're going to look into how to use those graphs to solve some trigonometric equations. And so let's go to the introduction video. Now, simple trigonometric graphs normally help us solve trigonometric equations. They can be complex equations, but this time around we're just going to have an introduction to them, and so we're not getting into tough trigonometric equations. Again, what you're going to do here will lay basis for more complex trigonometric graphs, which will be tackled later on in the course of time. And maybe as we begin, we just need to have a big idea of how the sine curve, the cosine curve, the tan curve looks like. And therefore, let's do this. We have a question there. Draw the graph of y is equal to sin x, y is equal to cos x, and y is equal to sin x for the interval 0 to 360 degrees. Again, this is going to help us appreciate how sine changes from 0, the sine of 0, all the way up to sine of 360. The same way for cosine of 0 all the way up to cos of 360, and again tan of 0 all the way up to the tan of 360 degrees. And therefore, let's get into it. Now, the first thing to do normally is when you're plotting the sine curve, the cosine or tan curve, is you draw a table where you have your degrees like this. These are the x values. That's what you're going to have on the x-axis, and then the y values will be either now the first curve, that's sine curve. We're going to have the values for y, which is sine of x, in our case sine of 0, sine of 30, sine of 60, all the way up to sine of 360 degrees. Similarly, you're going to have to plot these degrees again is the cos of 0, cos of 30, cos of 60, all the way up to the cos of 360 degrees, and similarly for tan of theta. Now, you're going to fill this table, first of all, the sine values, and again the cosine values and the tan values as they appear on your screen there. Normally, if you want to have more accurate graph, you need to have smaller intervals. These are intervals of 30 degrees, 0, 30, 60, 90, 120, all the way up to 360. But if you had, say, intervals of 15 degrees, it would be a lot more accurate. But this still serves a purpose. And so let's use this for now. So we have sine of 0 is 0, sine of 30 is 0.5, sine of 60 is 0.866, which is rounded off to 0.9, sine of 90 is 1, sine of 120 is 0.866, which is again rounded off to this, and that continues. Now, if you look at the sine of 180, again it's 0. 210 starts to become negative and goes up to a maximum of negative 1 at a sine of 270, and again starts to come towards 0 again, so becoming bigger number up to 0. And please understand that 0 and 360 are the same angles. Angle that is 360 degrees or 0 degrees is just the same angle. The cos of 0 is 1, cos of 30 is 0.866, which is rounded off to 0.9, and I'm just using single decimal place, and therefore that's what you have there. The cos of 60 is 0.5, and you just populate this part for cos of x. Now, some interesting thing about the tan, you should understand that tan increases from 0 towards 90, such that at 0, tan of 0 is 0, tan of 30 is 0.57 something, which rounds off to 0.6 in one decimal place. Sine of 60 is 1.732, but here we round it to one decimal place at 1.7, and it continues to increase such that when we're getting to 90, it becomes an infinite number. It's an infinite number here, and same case also for 270, it's infinite, and we shall see that in the actual graph. Maybe you just need to plot that. I've done the sine curve, and this is how it looks like. Yes, it goes that way. The sine of 0 is 0 and it continues to increase until the sine of 90 is 1. Looks like the y-axis value labeling is cut off here, but here we have 1. This is 0.5. Sine of 30 is 0.5, of 60 is 0.9. The sine of 90 is 1, and it increases up to 90, starts to come towards 0 again until it's 0 at 180, and does the same thing only on the opposite direction up to 270 and comes back to 360. So that 360 and 0 are the same, and the curve starts to repeat after that. So that's generally how the sine curve looks like. The cosine curve looks like this. It begins at the cos of 0 is 1, but it decreases until the cos of 90 is 0, and progresses in a similar way to the opposite direction until its maximum negative 1 at cos of 180 degrees, and it does exactly the opposite of that until it comes to the cos of 360 again, which is the same as cos of 0, and it is 1 that particular way. So the curve moves in that particular way, and that means that at the cos of 360 the curve starts to repeat itself. For the sine of 360 again, it begins to repeat itself, and so later on you will learn that it has a period of 360 degrees, that is sine, and the cosine, sine x and cos x, they have the period of 360 degrees. Again, what we call the amplitude, it goes up highest at 1 and again lowest at negative 1. And that's not necessary for this lesson. I just wanted to show you the general flow of the curve. So this is generally how the sine curve looks like, and this is how the cosine curve looks like. Interesting things about these two curves: one, they are continuous, and I'm saying that in comparison to the tan curve. And let's look at how it is, and you have it appearing there. Now the tan of 0 is 0, tan of 30 we say it is 0.6, rounded off to one decimal place. Tan of 60 is 1.7 something, and continues to increase until at 90 it's infinite number. And that's why the tan curve is not continuous like the sine and cosine curves. So here it goes on that way, it comes close to this line I've drawn here. It will also behave the same way at 270, but never touches the two lines. Now these lines are called asymptotes, to mean that a line that we are coming close to but never touching. So this curve will come closest possible to this line x is equals to 90 degrees, but it never touches it, and the same way also the other one there. And therefore this is basically how the tan curve looks like, and we're going to have to use these three curves to help us solve some trigonometric equations, and maybe we just need to get into that in the next video. Check it out, it is coming or being posted at the same time with this particular video. Always like, share, subscribe, I'll appreciate it. Thank you.